Global commerce moves on millions of identical brown boxes. It is the physical infrastructure keeping the supply chain moving every single second. Because they look identical, it is easy to treat packaging like printer paper or paper clips. You check a catalog, find a standard size, and buy the one with the lowest price tag per unit. This table exposes the trap. On the left, your invoice says you paid 50 cents for a box. On the right is your total landed cost. That box triggered a $3 dimensional weight penalty and $2 in replacement costs for transit damage. You didn't pay 50 cents, you paid $5.50. Chasing that cheap unit price means you are buying off-the-shelf, standard-sized boxes. They are almost always too big for your product and made with the wrong structural materials for your specific shipping network. To stop bleeding margins, you have to align your product's exact weight, fragility, and volume with specific corrugated engineering and the right type of manufacturer. A corrugated box is a structural engineering choice, and that choice directly dictates the health of your shipping margins. This 3D cross-section shows the architecture of corrugated board. Flat outer liner boards sandwich a wavy, fluted medium. For heavy appliances, you need maximum vertical strength, achieved by building a double-wall construction using thick, rigid A-flutes. But look what happens to the box itself. To maintain the exact same internal capacity, those thick walls push the outer dimensions outward. A bigger box means higher shipping costs. Contrast that heavy-duty build with a dense microflute profile, like an E-flute. These dense, thin flutes create a perfectly flat outer surface, ideal for high-end retail printing, but it offers very little shock absorption for a delicate product inside. Pick the wrong flute profile, and you force a choice between high transit damage rates or a compromised brand presentation. It is incredibly frustrating to buy packaging labeled high strength, only to have your expensive products arrive crushed or punctured. This matrix illustrates the difference between the two main strength ratings. On the left is burst strength, measuring resistance to an object striking the face of the box. You need this for single parcel networks where boxes get banged around. But burst strength tells you nothing about top-down pressure. Put that same box at the bottom of a heavy pallet stack, and it collapses. That is why we look at ECT, measuring vertical compression strength, which is mandatory for palletized freight. High puncture resistance cannot save a box from being crushed from above. Your primary shipping method, individual parcels versus pallets, must dictate the rating you buy. The physical integrity of the box is only half the equation. The other half is the financial penalty carriers impose for moving it. This graphic breaks down how carriers calculate dimensional weight, or dim weight. They take the physical volume of your box, length times width times height, and divide it by a standard divisor, typically 139. The resulting number is your dim weight. Look at the discrepancy this formula creates. The actual product on the scale weighs 8 pounds, but because of the box's size, the carrier invoices you for a 23-pound shipment. Buying standard off-the-shelf boxes that leave 2 or 3 inches of empty void space around your product is the direct trigger for these massive surcharges. By shifting to right-sized custom packaging, you can mathematically shrink your dimensional footprint by 20 to 40%. The trade-off here is upfront cost. Right-sizing requires paying for custom tooling and design, and it might lower your bulk purchasing leverage on standard sizes. But failing to invest in right-sizing means you are paying major carriers to ship empty air. Once you know your specs, you have to look at the origins of your raw materials. Who you buy boxes from is just as critical as what the box is made of. This chart maps out the supplier landscape. In the top left quadrant, with high volume but low customization, we have the integrated mammoths. These are massive, publicly traded corporations that own the entire vertical supply chain, from the forest to the finished box. They offer the absolute lowest unit pricing through massive economies of scale, but they dictate long lead times and prioritize massive volume clients over everyone else. Down in the bottom right quadrant, we have independent converters, or sheet plants. They purchase raw corrugated boards from third parties to manufacture custom finished products. Independents provide rapid iteration, highly optimized custom design, and short lead times. The trade-off is a higher baseline unit cost. Your required order volume and your need for specialized dimensions will ultimately dictate which tier of supplier will do business with you. Let's synthesize these variables and map specific business models to the exact corrugated architecture and supplier they need using this matrix. For a direct-to-consumer e-commerce brand, priority 1 is reducing dim weight and creating a premium unboxing experience. You want a single-wall e-flute box, and you need to partner with an independent supplier for maximum agility. For an industrial shipper moving heavy parts, it is all about pallet stacking strength. You require double or triple wall C-flute constructions, and you must focus entirely on edge crush test ratings over burst strength. Finally, the high-volume commodity shipper prioritizes scale and unit cost reduction above all else. A standard single-wall C-flute box works perfectly here, sourced directly from an integrated supplier to maximize volume discounts. In the logistics world, there is no universal best box. There is only the mathematically correct fit for your specific supply chain. Stop optimizing the invoice for the cardboard and start optimizing the invoice from the carrier. That is how you master your total landed cost.